Hi, in this video we turn our attention to periodic trigonometric functions. So these are the topics we'll be covering. Let's start with this first one, the unit circle and the sine function. Here we have unit circle. Remember that the sine of the angle is the y-coordinate of points along this circle. So that's what we're seeing here. As the angle increases from 0 to 90 degrees, the y-coordinate increases from 0 to 1, but not linearly. Notice how it grows. Of course, as the angle continues from 90 to 180, the y-coordinate drops from 1 back to 0, and so on. So let's look at this in a GeoGebra app that I found. So here is the app. So notice at this point the angle is 0, and of course the y-coordinate of this point is 0. We'll be capturing the y value on this graph over here on the right. So let's increase the angle. Notice as I increase the angle, the y value increases until it reaches about 90 degrees, and then the y value begins to decrease again. And we can continue doing this. Notice the y value continues to decrease, and then it starts increasing again. And so this could conceivably go on forever and ever. As we continue going around past 360, this would continue on to the right here. So that app can be found here. Now let's look at the cosine. Now for the cosine, remember that the cosine of the angle when using unit circle will be the x-coordinate. So at 0 degrees the x-coordinate is 1, and at 90 degrees the x-coordinate is 0. So they were not able to draw a line from here to here again because, well, this is on a vertical axis and our x-coordinate is horizontal. So it's a little bit harder to see, but you should be able to. The x value goes from 1 to 0 to minus 1 to 0. Notice here the x value is 0 and then back to 1. So from 1 to 0, minus 1, 0, and back to 1. Again, we have an app for that, and it's right here. So let's look at that app. So as you can see, at 0 degrees, notice the line is here. It's at 1 because the x coordinate is 1. This is 0.10. As we begin to increase the angle, notice the x coordinate begins to decrease, 0.669. Of course, when we reach about 90 degrees, the x value, the x coordinate is 0. And so we can continue to increase the angle, and notice now the x values are negative. Notice negative. We increase some more, and notice we get our familiar cosine. So here it's going to hit 0 again. Notice the x coordinate is 0 at 270 degrees. So this app uses degrees, not radians. You should be comfortable working with both. And so we'll stop about here. Again, this could conceivably go on forever and ever. As we go around and around and around, this would simply keep on repeating. This makes both the sine and the cosine then to be cyclic functions. So once again, this is where you can find this app. Of course, a more direct way of creating this graph is to simply tabulate values. So we have different values for x, and we calculate the sine, and then we plot these values. So the x values go along here, and the sine of x is on this y-axis here, and we get the familiar sine curve. Likewise, we can do the same thing for the cosine. We get these values, and we plot the cosine of them, and we see what we get, the familiar cosine function. So we now should be familiar with the cyclic nature of these functions. And all cyclic functions have what is called a period. So what is a period? Well, formally it's the horizontal shift that would make the function equal to itself. So let's look at this a bit more closely so that you understand. But before we do, we just want to point out that the smallest such horizontal shift that will make the function equal to itself, well, that is called the period. And so for a sine and cosine functions, you find that the period is 2 pi, or 360 degrees. So that's what we're seeing here. If I were to take this function and somehow drag it across, you would find that if I drag this point over to here, it would all overlap and you would not be able to see any difference. So then that is one period. Likewise here, if I were to drag this over this amount, the functions would just land on top of each other and you would not see any difference. You would not know that I moved this function. So if I shift this a little bit, you'd know I moved it. But if I shift it until this point is here, or in this case until this point is here, or until this one is here, then you would not be able to tell that I had moved this at all. And so that shift then is going to be one period, and that's 2 pi. Another way to look at this is that you can see that after 2 pi, the function simply repeats itself. Likewise, I can start here and we see, after 2 pi, it repeats itself. Note I don't necessarily have to start here. I can start here. And notice 2 pi later, I'm going to repeat myself. Likewise, I can start here. And 2 pi later, I'm about to repeat myself. Okay, so let's look at this using GeoGebra. So here is a little GeoGebra app. I have two functions here. A green one that you can't see because it's right under this one, and then this red one. And so they're both sine of x, but this one actually is sine of x, and then it's actually x plus a. And what I'm going to do is I'm going to vary the value of a. So let me just drag this out a little bit more so you can see it. So x right now is 0.01. So let me just move it back. Notice it disappears. Let's increase the value of a. So if a is increasing and becomes positive, this should then move to the left, right? At what value of a will the two functions overlap again? So let's take a look at that. So I'll just go increasing them. Increasing the value of a. Notice what's happening. You can definitely see that there are two different functions here. This function and this function are definitely not the same. But notice what's happening, right? So look at the value of a, it's 4.97. So remember what 2 pi is. 2 pi is approximately what? 6.28, right? That's 2 times 3.14. Remember, that's an approximation. So we continue and notice we're getting close to 6.28 now. Alright? And notice at 6.28 we have perfect overlap again. So what shift did it take for these two functions to overlap? Well, 2 pi. Notice I could continue and it would overlap again. I don't have enough values here, but if I could increase this up to 4 pi, then of course they would overlap again. But the minimum displacement, the minimum horizontal shift that will cause the overlap, well, that's a period. So notice if I bring this back to 0, we're back where we started. Let's make this negative now. Again, notice how far do I have to shift it over? Now it's approaching pi. And then 2 pi. Notice this number is approaching minus 6.28. Notice, so almost there. So you can focus here or here. Notice, overlap again. So obviously then, the period of a sine function is 2 pi or 360 degrees. We can do the same thing for the cosine. Note that this is actually the cosine of x plus a, but a is 0. So let's go increasing the value of a. So again, notice we get that horizontal shift, and at 6.28 the functions will overlap again. So horizontal shift of 6.28 will cause the functions to overlap and be identical. So the cosine of x is equal to the cosine of x plus 2 pi, and therefore the period is 2 pi, because this is the minimum shift that would cause overlap. Note that the cosine of x and the cosine of x plus 4 pi would also overlap, but 4 pi is not the period because 4 pi is not the minimum shift that would cause overlap. 2 pi is the minimum shift that would cause overlap. Let's look at a couple more items before we close this video. Note that the sine function exhibits odd symmetry, and also the cosine exhibits even symmetry. So the sine function is odd and the cosine function is even. So these are the characteristics of the sine and cosine functions. Make sure you know these. The domain in both cases is from minus infinity to plus infinity. The range from -1 to +1. The period is 2 pi. The sine is odd. The cosine is even. Now I wanted to look at this in this video, but we are already at about the 10-minute limit, so this will take me more than a few minutes to do. So I will talk about sinusoidal functions in the next video. Note that sinusoidal functions are simply sine functions that have been transformed, or cosine functions, and so you should know what this means, right? For example, this is the vertical displacement, this is vertical stretching or compression, etc. So okay, we'll get back to this in the next video. Thanks for your attention. See you in the next one. Bye for now.